Okay, next subtopic, we are going to look at the architecture of IoT. This is the architecture from the viewpoint of product stack. As we see, this basically the interconnection of devices. For device to be connected together, we need some rules. This is so-called protocol. Since the protocol has to cover lots of things to do, so we have to partition the protocols into different tiers. This is what we mean the protocol stack. Okay, from this viewpoint, the IoT architecture, it represents is equally the product stack of the IoT. There will be three different layers. Okay, from the bottom to the up, we will see the first layer is a so-called sensing layer or the processing layer. This layer will be in charge of data gathering and exchanging data between devices and also collect data, send out upward, through internet to the back end for processing. Okay, the second layer, middle layer, is so-called networking layer. This layer will be in charge of data processing, formatting, and propagation. Okay, to the left, you will see we have braces to connect these two layers together. That means, in general, in IoT devices, okay, networking layer and sensing layer basically will be combined together. That means there will be devices with the capability of sensing and also embedded with the networking capability at the same time. Okay, the uppermost layer will be the application layer. The application layer will be the design for the usage. It covers the data collected, received from the sensing nodes. We call it data storing. Okay, since in most cases the data will be gathered in a very high speed. For example, we do the telemetry. We measure some geographic information, one data per second. Okay, there are lots of data has to be propagated through networks back to the application layer, okay, for processing. So for IoT, first we need so-called big data. Okay, since we have lots of big data to process, and we need a lot of computing powers for processing. Okay, this is the second requirement, which is so-called cloud computing. So anytime we talk about IoT, it always associated with the big data and cloud computing. Okay, anyway, back to the application layer. They are also, based on the data collected, we do the analysis. Then we do the presentation. So the IoT in application layer will be not only provides the information, but also the intelligence. We have to learn something. We have to provide certain kind of suggestions from the data we collected. Then this is the purpose of designing the IoT. This is basically the architecture. This is the simplest way to look at IoT architecture, sensing, networking, and application. Okay, so in what follows, we'll look at the sensing, networking, and application. But basically, in the design of these sessions, we combine the application into the session. Since once we talk about the perception, we have to do the associated connections to the application. So these two will be combined together for introduction. And also we look at the networking layers, see what kind of main technology applied for data propagation. Okay, so look at how the sensing layer to get the data. Basically, it will be through various kinds of sensors. Okay, here we categorize the sensors based on the operations. So we have electrical related, mechanical related, and so forth. First, we look at these slides. Electrical related, we have voltage sensor, current sensor, power sensors. Voltage sensor means we can not only detect the voltage, the existence of voltage, and also we can set up a threshold for a voltage, so we can provide certain kind of signaling, such as alarms, to notify the voltage has been over a certain range. Okay, current, power will be the same purpose. Okay, so this is the electronic or electrical related applications. The second one is the mechanical related. We have accelerometer, gyroscope, and distance sensors. Look at the figures below. The leftmost one is the three-axis accelerometer. Accelerometer means we can measure the change of velocity in three different directions. Okay, so this is the accelerometer modules. Basically, we make these modules smaller into an integrated circuits, and we'll put these modules in certain devices. Here is an example. This is a smartphones. In most smartphones, they all equipped with the accelerometer. Okay, so accelerometer can measure, as you see, the X, Y, Z, three directions. That means if you have cellular phone, when you activate the accelerometer, okay, it can measure the moving speeds, the change in the speeds of the cellular phone. Okay, so we can measure the X direction, Y, and Z. That means we can measure the movements in the front and back, left to right, and vice versa, and also up and down. Okay, so this is what we mean the accelerator. Gyroscope, or in short, we call it gyro. It's measure also the basically measure the directions, orientations, changes in orientations, and also in three directions. Next slide, we have a bit comparisons for these two devices. Okay, the last one is called the distance sensors. This uses the infrared or lasers. Then we emit the lights and receive the lights. Then based on the delay times, so we can calculate the distance. Since we know the light speeds, the infrared or the laser will be propagated in light speeds. You know the times from the lights you emitted when you detect the light back. Okay, then you know what the time elapsed. Then you can calculate the distance. This is the operation principle of the distance sensors. Okay, now we can see more. Okay, this is a slide as we said. You can look at the difference between the three axis, three direction accelerometer, and the gyroscopes. Okay, you can take a look. So first, basically the accelerometer is measure change in velocity in three different directions. You know the change in velocity, that means the accelerity. Then you can, based on the simple physical formulas, can calculate the moving distance and so forth. Okay, gyroscope measure the orientation, the directions, means the angles, and also change the rotation velocity. This is the basic principle of the gyro. Okay, so this difference between these two devices. Okay, again, you look at the bottom, we have the URL. If you like to know, to see more detail on the differences between the accelerometer, gyroscopes, okay, you can look at the web pages. Okay, next we look at the magnetic related. The most popular one is the magnetometer. Okay, magnetometer is basically measure the magnetic field. Chemical related can measure some dust or some environmental informations. For example, we have two samples here. One is dust sensor, can measure the cigarettes. Another one, we can measure the CO2, carbon oxide to exists in environment. Okay, so if you like to know the environmental, the air pollutions, this kind of sensors will be useful. This is what we mean the sensor. Basically, those sensors, once operated, the sensing the data have transduced to sensing the signals, sensing the physical changes, mechanical changes. Okay, you have to convert signals to data, then transmit it out. So if we look at sensors, it's not only the sensing devices, the components, it also includes some microchips, processing units to combine those together. Otherwise, there's no data can be transmitted out.